7 visitors are hurtling towards Earth. While that headline sounds like science fiction, the reality is that in late 2025, a remarkable parade of comets will grace our skies. Among them is 3I/Atlas, only the third interstellar object ever detected. This celestial convergence is an extraordinary event, pushing the boundaries of what our sky surveys have ever witnessed. Is this just a rare cosmic coincidence? Or are we seeing a new chapter in astronomical discovery? The answers and the spectacle begin here. Let's explore this together. The digital skywatchers. Have you ever wondered who finds these cosmic travelers? Every night, a silent network of digital eyes sweeps the heavens. These are the world's automated comet hunters, primarily the Pan-STARRS project in Hawaii and the Atlas survey, a NASA-funded project with telescopes in Hawaii, Chile, and South Africa. Led by principal investigator Dr. Larry Deneau, the Atlas system is designed to scan the entire sky every 24 hours to identify moving objects. Their cameras are incredibly sensitive, able to spot objects down to magnitude 21, which is over 100,000 times fainter than the faintest star you can see with your naked eye. The Pan-STARRS. PS1 camera is a 1.4 gigapixel behemoth, capturing several terabytes of data each night. The real prize isn't a static picture, but movement. Sophisticated software compares new images against a vast digital map of the cosmos, flagging any pixel that is shifted. Once a candidate is flagged, an alert is sent to the Minor Planet Center, where Dr. Matthew Holman and his team process the data, triggering follow-up observations from around the globe. They are joined by other powerful surveys like the Zwicky Transient Facility in California, creating a planetary defense network of unprecedented capability. The entire process from initial detection to confirmation can happen in less than an hour. This digital vigilance has completely transformed the field, turning comet discovery from a waiting game into a real-time hunt. 7 against the odds. How rare is an event like this? According to comet population modelers like Dr. Kwanji Ye at the University of Maryland, the universe is usually stingy with its showstoppers. In a typical 6-month stretch, statistical models predict we should see 2, maybe 3, comets bright enough for backyard telescopes. Late 2025, however, throws a wrench in those models. 7 significant comets are scheduled to reach perihelion in a single half-year, an event that stands out as a major statistical anomaly. Running Monte Carlo simulations with data from current surveys, the probability of 7 such comets appearing in one season is less than 0.5%. Some models place the odds closer to 1 in 1,000 years for a grouping of this brightness. This rarity is governed by random gravitational nudges from passing stars, or the galaxy's tidal forces, that send comets from the Oort cloud on their million-year journey toward the Sun. For comparison, not even the famous Great Comet year of 1811 saw such a dense clustering of arrivals. This 2025 event will provide an invaluable data set to refine our understanding of cometary dynamics and the true population of the outer solar system. The quiet visitors. Not every comet is a headline grabber. Some slip through the solar system as faint smudges, their passage noted only by dedicated observers. Among the 7 visitors of 2025, 2 fall into this quiet category, C/2022 E3 or Pan-STARRS and the periodic comet 240P/NEAT. C/2022 E3 reaches its perihelion on July 31st, at a Chile distance of 3.82 astronomical units, or about 571 million kilometers from the Sun. At that range, it's not expected to brighten beyond a modest magnitude 10, visible only in medium-sized telescopes. Then there's 240P/NEAT, which was discovered in 2002 and returns every 7.6 years. It makes its pass on December 19th at a distance of 2.12 astronomical units, or 317 million kilometers. Its performance will likely be even dimmer, a low-key encore for those tracking its well-documented path. For both of these objects, the primary audience will be astronomers contributing data to the Minor Planet Center, where every verified observation helps refine orbital calculations. Even these faint comets provide crucial data on things like nucleus rotation and the slow development of their comas. They are the workhorses of cometary science, providing a baseline of normal activity against which the brighter comets can be compared. The crowd pleasers. Ready for the main event? For anyone who has wished for a comet bright enough to rival the stars, late 2025 offers 3 incredible opportunities. Comet forecasters like Gideon van Buitenen are predicting a spectacular show from C-2025 R2, also known as SWAN, C-2025 K1 or Atlas, and C-2025 A6 or Lemon. First up is Comet SWAN, which makes its closest approach to Earth on October 21st, passing just 37 million kilometers away, less than a quarter of the distance to the Sun. It's predicted to reach a peak brightness of magnitude 2 or 3, making it easily visible to the naked eye at dawn. Before that, on October 8th, Atlas K1 barrels in, reaching its perihelion at a scorching 0.33 astronomical units from the Sun, triggering furious outgassing of sublimating ices. Finally, Comet Lemon makes its closest pass on November 8th, with forecasts suggesting it could brighten to magnitude 3.5, making it a prime evening target. Keep an eye out for a distinct greenish glow in their comas, a hallmark of diatomic carbon or C2 being energized by solar radiation. However, comet brightness is notoriously unpredictable. A sudden outburst could make one of them even more spectacular, or they could fizzle out unexpectedly. This uncertainty is part of what makes comet watching so exciting. Spacecraft Symphony. What happens when a comet is hiding in the sun's glare? Some of the 2025 visitors, like 414p/stereo, will be almost impossible for us to see but will be front and center for a fleet of solar spacecraft. On September 27th, 414p reached perihelion at just 0.504 astronomical units, or 75 million kilometers from the Sun. From our perspective, it will be lost in the bright sunlight. This is where missions like SOHO and Stereo, and experts like Dr. Carl Badams of the Naval Research Laboratory come in. Their coronagraphs, like SOHO's LASCO instrument, are designed to block the sun's direct light to monitor solar storms, giving them a perfect view of sun-grazing comets. These instruments can reveal details about their activity that ground-based observers completely miss. In addition to images, spacecraft like the Parker Solar Probe and Solar Orbiter could use their plasma detectors to directly sample the material in a comet's tail if their orbits align. This would provide an in-situ measurement of the tail's composition and its interaction with the solar wind, which travels at speeds over 400 kilometers per second. These missions offer a completely different perspective, turning the entire inner solar system into a coordinated laboratory. The 6-month marathon. Imagine a cosmic traffic jam. That's what the inner solar system will look like from late July through December 2025. The marathon kicks off with the distant pass of C-2022 E3 or Pan-STARRS on July 31st. Then the pace quickens. On September 27th, 414p/stereo slips past the Sun as spacecraft watch. October turns into a celestial rush hour. On October 8th, Atlas K1 dives toward the Sun, followed just 5 days later on October 13th by the interstellar outlier 3I/Atlas on its unique hyperbolic path. On October 21st, Comet SWAN makes its close approach to Earth, followed by its perihelion on October 29th. Comet Lemon takes the stage with its perihelion on November 8th, drifting into dusk skies. Finally, on December 19th, 240p/NEAT rounds out the sequence. This compressed schedule creates an intense competition for observation time on major telescopes like the VLT and Keck. Wide-field imagers may even capture multiple comets in the same frame, a photographic opportunity that is almost unheard of. This non-stop stream of data will allow scientists to compare and contrast the evolution of multiple comets under similar solar conditions in near real time. Tales of two tails. Why do comets have tails? And why do they sometimes have two? The answer actually goes back to the 1950s, when German astrophysicist Ludwig Biermann first proposed the existence of a continuous solar wind. He was right. Every comet grows at least one tail and often two as it nears the Sun. The dust tail is broad, curved, and pale, made up of silicate and carbonaceous dust grains that are pushed away by sunlight. This tail can stretch for over 10 million kilometers, with its particles moving at a relatively leisurely pace of a few hundred meters per second. The ion tail, on the other hand, is a straight, narrow blade of electric blue, formed when the solar wind ionizes gas molecules like carbon monoxide. The solar wind then grabs these ions and hurls them away from the Sun at hundreds of kilometers per second, creating a tail that can exceed 100 million kilometers in length. The blue color comes from fluorescence, mostly from ionized carbon monoxide or CO+. If the geometry is just right, observers on Earth may even spot what's called an anti-tail, where dust in the comet's orbital plane appears to point toward the sun. These two distinct tails offer a direct large-scale visualization of the invisible forces shaping our solar system. When solar storms strike. Did you know a solar storm can rip a comet's tail clean off? When a powerful coronal mass ejection, or CME, erupts from the sun, it carries with it a tangled mess of magnetic fields. If a comet is in the crosshairs, the result is just spectacular. As observed by Dr. Geraint Jones and other heliophysicists, the comet's ion tail can be completely severed in a matter of hours. The most famous example occurred on April 20, 2007, when NASA's Stereo spacecraft watched a CME traveling at over 500 kilometers per second slam into Comet Encke. The mechanism behind this is called magnetic reconnection, where the sun's magnetic field lines and the comet's field lines abruptly snap and reconfigure, releasing a massive burst of energy. The severed tail is left to drift in space, a ghostly, disconnected cloud that slowly fades from view. These disconnection events provide a natural probe, allowing scientists to measure the speed, density, and magnetic orientation of the solar wind at the comet's precise location. With 7 comets in prime positions, the 2025 season could become a masterclass in space weather physics. The Interstellar outlier. What happens when a visitor from another star system drops by? Nothing in the 2025 lineup is as scientifically valuable as 3I Atlas. It follows in the footsteps of 1I Oumuamua and 2I Borisov, which gave scientists like Dr. Karen Meech our first chance to study material from other star systems. Early observations of 3I Atlas from the James Webb Space Telescope are already staggering. The coma, its glowing envelope of gas and dust, has been measured at nearly 700,000 kilometers across, half the diameter of the Sun. The nucleus is ejecting fine dust at a rate of 6 kilograms per second. What's truly shocking is its chemistry. Spectroscopic analysis reveals an 8-to-1 ratio of carbon dioxide to water, a composition unheard of in solar system comets. This implies 3I Atlas formed in a region of its home star system that was far colder than our own Kuiper belt, below the CO2 frost line. The most tantalizing possibility, however, is that simulations show its dust trail may cross Earth's orbit in mid-2026. This could create the first-ever meteor shower of interstellar material, allowing us to capture and analyze dust from another star as it burns up in our atmosphere. Windows to wonder. So, how can you see these cosmic visitors for yourself? Mark your calendar for the morning of October 21st. Just before sunrise, look to the east in the constellation Leo to catch Comet SWAN at its closest approach. If predictions hold, it could shine at magnitude 2 or 3, a bright star-like object with a faint tail. A few weeks later, the evening sky gets its turn. From November 6th to the 12th, Comet Lemon will slide into the western sky just after sunset, likely in the constellation Ophiuchus. It's forecast to reach magnitude 4, an easy target for binoculars from the city. The best time to look is about 30 to 60 minutes after sunset. For both events, a simple pair of 7 by 50 or 10 by 50 binoculars will work wonders. To get the best view, find a location far from city lights and give your eyes at least 15 to 20 minutes to fully adapt to the darkness. Use a stargazing app on your phone with a red light filter to find the right constellations without ruining your night vision. This small amount of preparation can be the difference between seeing a faint smudge and a truly breathtaking cosmic sight. The Great Comet Parade of 2025 is more than just a rare celestial alignment. It's a profound reminder of the dynamic, ever-changing universe we inhabit. From quiet, distant travelers to brilliant crowd pleasers and even a visitor from another star system, this event offers something for everyone. It's an unprecedented opportunity for scientists to study these icy relics in real time, and for all of us to connect with the cosmos on a personal level. So, get your binoculars ready, mark your calendars, and prepare to be amazed. This is a sky show you won't want to miss. Don't forget to like, subscribe, and hit the bell icon for more updates on this cosmic event. Thank you for watching InnoVision Tech.